In this video, we're going to walk through the solutions to this practice problem, looking at expanded octet Lewis dot structures. If you haven't tried it, stop the video and give it a shot first before watching. So we're going to try two. We've got phosphorus bonded to 5 chlorines, and then we have phosphoric acid that we're going to look at. Now, phosphorus commonly has 10 valence electrons, but phosphorus is in the third row of the periodic table, so it can expand its octet. So let's walk through each of these. So my phosphorus is right here, has 5 valence electrons typically, and I would draw it like this normally. But I have 5 chlorine atoms, and it's a neutral molecule, so I can't add electrons or take electrons away, and I have to make this work somehow. Chlorine has has 7 valence electrons, and so it really just needs one bond. I can't put more to it. Well, I can because it's also in the third row or below, so it can expand its octet. But in this case, we're going to expand the octet for phosphorus. So I can imagine creating a Lewis dot structure where I've got 3 chlorines and I'm feeling really good about it. And I'm like, great, but now I have to add 2 more. And so what happens is we take a look at this lone pair and we kind of split it up, at least for drawing the Lewis dot structure. And what we'll do is we'll form bonds to the other 2 chlorines with the electrons that we had previously put in a lone pair. And normally I say once we have those electrons as a lone pair from our Lewis dot structure, leave them alone. And here I'm saying now you got to break them up. And we're only going to do this if it's in the third row or below. And I will let you know that I want you to expand the octet or not if I want you to do one specifically. All right, let's look at the next one. Hydrogen, phosphorus, and oxygen. So I've got some hydrogens. These each want 1 bond. I've got phosphorus. This typically wants 3 bonds. And I have oxygen that has 6 valence electrons, so typically wants 2 bonds. And I've got 4 of these, and I have 3 of my hydrogen and 1 of my phosphorus. So there is a way to solve this structure so that it follows the octet rule. I'm purposely going to break it, and I'm going to build the structure that we see actually out in nature more often. And so this phosphorus is the only one that is in the third row or below. So this is the only one that can expand its octet. Oxygen can't do it because it's in the second row. Same with carbon and nitrogen and fluorine. These will never expand their octet. They don't have d orbitals to use. So I'll start with the expanded one in the middle. I've got my phosphorus. I'll put my valence electrons around it. And now I'm going to start building this out. So I'm going to put my oxygens next because they need 2 bonds instead of 1. All right, and at this point, I can see that I have 3 hydrogens, and those 3 hydrogens would pair very nicely with these 3 unpaired electrons on the oxygens. But that leaves me with another oxygen atom. And so what I'm actually going to do with this is I'm going to pair it up here. And I'm going to bring one of these oxygen atoms to participate in a double bond with the lone pair on the phosphorus. And so I'm going to get a structure then that looks like this. I'm going to do a little erasing. Like that. So I'll have a double bond. Then my hydrogens can come in and they can form a bond to my oxygens like this, which is fantastic. So now I'll redraw this so it's clearer. I'll have a phosphorus double bonded to an oxygen, and then each of my oxygens will be bonded to a hydrogen. And my oxygens all obey the octet rule, my hydrogen obeys the duet rule, and my phosphorus has 10 electrons around it. It expanded its octet.